Hi, my name is Doran. I'm an oceanographer with the U.S. Geological Survey, St. Petersburg Coastal and Marine Science Center. My co-authors today include Meg Palmston and my colleague Emily Himmelstas from the USGS Woods Hole. I'll be talking to you today about USGS forecasts of total water level and coastal change hazards along the U.S. Gulf Coast. This work is a large body of research under the USGS Coastal Change Hazards Program focus area, where our goal is to develop advanced capabilities to observe, understand, and forecast changes to the nation's coast with immediate and long-term applications. We do this through two primary web portals, the Coastal Change Hazards Portal and the Total Water Level and Coastal Change Forecast Viewer that I'll be showing you today. We're part of a three-center research, and we are made up of a diverse group of researchers, technicians, and communicators. Our goal is to integrate the research products that are useful to our stakeholders and, of course, stakeholder feedback in our life cycle of our project. The Coastal Change Hazards Portal provides national scale assessments on multiple coastal change hazards, extreme storms, shoreline change, and sea level rise. What you're looking at here is one of our forecasts of the probabilities of dune erosion, overwash, and inundation for Hurricane Sally. Presented in the three bands are the probability that the coast will experience dune erosion or collision during Hurricane Sally. The middle strip is the probability of overwash, that the waves and surge will overtop the dunes. And the outer strip is the probability of inundation, or tide and surge will overtop the dunes and flood the coast behind the dune line. These are available for extreme storms that threaten our U.S. coastlines, and we also have them available for generalized hurricanes and extratropical storms of varying intensities for planning purposes. Some of our other coastal hazards include sea level rise and shoreline change. The Coastal Vulnerability Index provides a metric of the relative susceptibility of the nation's coast to sea level rise and incorporates other data sets such as long-term shoreline change and geomorphology. The long-term shoreline change and historical shorelines are also available in the portal. We also have a probability of shoreline retreat that's based on a Bayesian network and incorporates the data from the Coastal Vulnerability Index. For the Gulf Coast, you'll see that the area around Louisiana has a high susceptibility to shoreline retreat due to sea level rise. Hot off the presses is a new data set that's now available in the portal. It's the unvegetated to vegetated marsh ratio that's available for salt marshes around the United States. This is a metric that measures a percent water to land ratio in marshes and can be used as an assessment of vulnerability to wetland loss. Our second tool that I want to share with you today is the Total Water Level and Coastal Change Forecast Viewer. This viewer presents real-time predictions of coastal water levels for management and planning. It's a 6-day forecast of water levels and coastal change that identifies the location and timing of a potential impact. So it's different than the event-based probabilities of coastal change that are presented in the portal, in that this is a continuously operating forecast and is available every day. When you dive into the viewer, you'll see that there are a series of colored dots. Each dot represents a weather forecast office, and that's where the wave models are run. The color of the dots indicates the likely coastal impact. So whether it's green, no impact is expected. Yellow, we're expecting dune erosion. Orange is overwash, and the red is inundation. When you click on a region in the Total Water Level and Coastal Change Forecast Viewer, you're going to be brought into the region where you'll see the alongshore spacing of forecast sites. They're about every 500 meters along shore. You'll also see the time series of water levels, hourly water levels for a 6-day forecast. You'll see also the elevation of the dune toe in the dashed line and the elevation of the dune crest in the solid tan line, along with the forecast of the mean water level, so tide and surge in the dashed blue line, and in that tide, surge, and wave run-up in the solid blue line. The light blue envelope is the uncertainty in the beach slope that feeds into the wave run-up parameterization. Below the time series, you'll see an animation of that water level with a dune profile. This is a really helpful visualization for people who aren't familiar with tidal levels and water levels on the coast, because it shows how much of the beach might really be inundated on any particular day. The colors of the dune will change with the predicted dune impact. This total water level and coastal change forecast is a collaboration with NOAA, National Weather Service, and National Centers for Environmental Prediction. They're providing the hydrodynamic model inputs, tide, surge, and wave conditions. And the USGS is providing the wave run-up parameterization, the beach slopes that go into that parameterization, and the coastal dune crest and toe elevations. Both the Coastal Change Hazards Portal and the Total Water Level and Coastal Change Forecast Viewer were developed in collaboration with stakeholders and users. As we move forward with improving these portals and adding more web tools and portals for our users, we are really diving in to stakeholder engagement and communications. We do this through public outreach, through stakeholder workshops, and of course through our important partners like sea grant agents. We know it's really important to get the stakeholders to tell us what their needs and problems and coastal concerns are before we go about producing a tool that nobody uses. So to conclude, some of our successes are that we have robust and accessible coastal change assessments that help improve the lives, property, and economic prosperity of the nation's communities, habitats, and natural resources. Some of our challenges are that national scale assessments might miss important local details, and that's where some of you come in. We have a lack of validation data for storm events. It's really hard to collect beach profiles and water level measurements during a storm. And we still have challenges connecting to our stakeholders and public users. And we could certainly use a few more social scientists and communicators as part of our research group as we really look to increase that capacity within our Coastal Change Hazards program focus and the USGS and Department of Interior in general. Thank you.